Story of the Perfect Amplifier. The audio amplifier has some magic attraction to the audience and engineers who are trying to make a perfect unit since I remember it. In consumer shows we can see large variations of power amplifiers in size, power, dimensions and design. Is it possible to make perfect amplifier for everybody? In this video I will cover the complete design process of how to develop a perfect amplifier aiming exceptionally to sound quality. This video is just another story about how to build a perfect amplifier, where I will cover analysis of each critical component involved, chosen amplifier architecture, sales and marketing strategy for product commercialization, slightly touching such a sensitive topic as human beliefs and expectations, as well as make short competitor analysis. How does it start? Sometimes small things are making large impact. After I published my first amplifier design story, one of the YouTube listeners, Roberto, put a short comment, asking how to improve my DI design by adding good preamplifier circuit. This short message triggered an idea to build a perfect amplifier meeting most demanding audiophile requirements, at the same time keeping costs reasonable. The open question was, is it possible to commercialize such a design? Actually, it's not a simple question. There are so many good designs out in the market. But everything is possible when we are focused and apply a systematic approach. My first step was understanding target audience, in my case, people who value high quality audio. Then study competitors and understand the market. In simple words, I need to do serious market research to find out where is the place for my new design idea. I did two parallel studies, the audiophile market and the professional market. Some of my findings I will share with you in the following slides. Audiophile world. When you are talking about perfect amplifier, you need to drill down and understand what meaning is behind it. Audiophile world and high-end audio is a very sensitive audience where many opinions and decisions are not 100% rational. I would compare it with people who believe in something. If you look back to history, people beliefs always was strengthened with sacrificing something. Inca people in South America sacrifice children believing that it will bring them better life. Catholic Church demands priests to give up family. Aztecs has a bloody ritual sacrificing animals and human lives. When we do such sacrifice, our way back is really hard, or in reality almost impossible. When I drilled down in hi-fi and high-end audio topics, I was surprised about the prices and mounted jewelry type of equipment with massive golden plated knobs, heavy metal parts and super nice looking front panels. Does it improve the sound? No, this is sacrifice. Audiophile community sacrifices some money. Most of audiophile market dedicated products are heavily overpriced. Even a simple film capacitor is covered with golden rings and terminals, being 10 times overpriced to mainstream products. But any engineers know those good capacitors are produced in a few large factories. The technology process is expensive and the price is a matter of economy of scale. Nothing will change in parameters when you finally put some of those units in golden plated plastic cover and trade it with a multiplier of 10. It is a million words question what the audiophile community is looking for. Is it audio quality or something else? Even today, after studying tons of forums, I don't have the answer to that. But if you talk about a real audiophile, you will meet rational and irrational combination, where the most dogmatic statement is following. In a music production there are things that humans can hear but engineers can't measure. This is a moment where I would argue that human hearing is far from the perfect instrument, heavily impacted by brain activity. We do have a powerful digital sound processor in our head that we can tune by our consciousness and compensate shortfalls of sensors. If we want to hear something and focus on that, after some time our brain will create it. Let us take a simple example. We want to record nice spring singing birds. We take it over to nearest riverside, there are a lot of birds. We record them with a good microphone and recorder. Going home and playing back on a large speakers, we are surprised to hear river water passing under the bridge, running highway, and by the way there are birds somewhere in the background. In a moment of recording, our consciousness gave a signal to hear birds and DSP processed it accordingly. At the riverside, we want to hear the birds and brain activity focused on the task. This is a reason why blind listening tests frequently give unexpected results. Today engineers are capable to measure any aspect of audio. If you are adding superior element in your system and not able to measure impact and output, but hear an improvement, there is only two explanations. Either you don't know how to measure it, or it's just a placebo effect done by brain DSP. Unfortunately for us, marketing found it out and created an elite club named high-end audio, where the sky is the limit of pricing and fancy designs. In this video, I will show a complete path to perfect audio amplifier, where each component and engineering decision will have a proof, answers and explanation how it will impact the end result. My ultimate goal is to make a perfect power amplifier covering 95% of audiophile and professional application needs. Why not 100%? The last 5% of quality is very expensive, and honestly say I'm not sure that I do have the necessary knowledge and resources to cover it. For those who are ahead of market with research and development department like ICEpower and Hypex, and we will learn from them and be one of the first implementing new discoveries in our designs. Marketing is a powerful science with a goal to create demand and seed messages in our heads. The audio amplifier has around 20 parameters to be objectively evaluated regarding sound quality. As consumers, we are only aware of some of them, like RMS power, total harmonic distortions, frequency response and flatness. Those are important specifications, but not sufficient to make objective decision about audio amplifier quality. Let us remember what scientists discovered regarding the human hearing limits. It is scientifically proved in the distortion blind test results that the human hearing limit of total harmonic distortions is 0.1%. Now think, what is your emotional reaction of specs indicating that total harmonic distortions is below 0.1% across all audio spectrum? By default, it should mean that the amplifier is good. Is it working like that? Yes, you are right. It doesn't work for the audiophile and consumer market. The right messaging is that total harmonic distortions is 0.003% at 1 watt. Second, the hearing limit for a flat frequency is 0.25 decibel. This parameter is far more difficult than total harmonic distortion when we are talking about a complex speaker crossover cases, especially for three-way speakers. Tricky thing is that total harmonic distortions and the frequency grabs of audio amplifiers are measured to the resistive load. This is an easy test. Real speakers has crossovers with complex impedance, and amplifiers should deal with the loads far worse than 4 ohms. Such parameters as a capability to drive 2 to 3 ohm load, damping factor, group delays, sleeve rate may be even more important than total harmonic distortions when driving 3 or 4-way speaker systems with complex crossover designs. Big brother Mackintosh. Before to start design, let us take some knowledge from named manufacturers with long development history. In this picture you can see Mackintosh top-line amplifiers. Let's try to read between the lines. The good amplifier should be powerful, minimum 300 watt and more. I would say 500 watt is optimum. Don't understand me wrong, we are not going to listen it at max power. We need the power to be able to operate in most linear power range far below clipping with solid power headroom. Practically any speaker is able to sustain undistorted music signal at least 4 times to RMS power for a period of time. The worst enemy of speaker is distorted signal, what may create DC component and burn your speaker units. It sounds strange, but a low power audio amplifier is more dangerous to your speaker than high power unit. Mackintosh is a well-established brand with rather polar forum reviews all around its high-class amplifier. Let us listen to company engineers what they are saying about their products and try to read between the lines.
I'm Charlie Randall. I'm the CEO of Mackintosh Laboratories. In 1956, we built the main facility, which is what we're at today. One thing that's unique about Mackintosh, the company is completely vertically integrated. Basically in here is where we process all of our sheet metal, which is anything on the amplifier, preamplifier, all the products that you see painted black. That material by itself represents about 1/3 of the cost of the Mackintosh product. So it's a very expensive material, but it's also a very highly cosmetic material.
What did we hear? Cosmetic parts comes at 30% of the unit price. And there is nothing about audio. It is all about the jewelry. And this is a million worse question as we spend money on audio quality or amazing designs. Definitely we need both, but could you imagine how good speakers we can purchase for saved money? And let us remember that speakers are 70% of audio quality, maybe even more. Nevertheless, in my opinion, such a large designs will disappear during the next decades. The kilowatt amplifier weight is 70 kilo. It's more than young female weight, and you need 2 persons to move it. 600 watt unit weight is 44 kilos. 300 watt unit weight is 30 kilos. Modern amplifier designs are smaller and lighter. Extra metal parts come with a cost of 30% of the unit price. It's a lot. Actually, metalwork costs there are higher than the total cost of the modern design amplifier. Now let's look at the Bryston top-line Cube models. Bryston is a strong name, and I personally like designs and company philosophy. By the specification, this is a state-of-the-art 300 watt amplifier, but it comes with extra cost of metal and efficiency. Look at efficiency parameters in the power section. To deliver 300 watt, we need to provide 700 watt power and dispatch 400 watt of heat. At some point, this design direction is moving to nowhere as well. In my personal ratings, Bryston is the #1 name in the high-end amplifier design. This company philosophy about amplifier design and concept is in sync with mine. I'm buying a concept, I'm buying another architecture, and I'm confident that those units will do the job. Am I ready to pay price? No. I want 10 times smaller solution doing the same job. Now let us listen to James Bryston, one of the big names in audio industry.
I'm here with James Tanner Bryston. Good morning.
Good morning, Peter.
Bryston is one of the hallmarks of the high end. How long has it been in business?
We started in the mid-70s, and Bryston originally was a medical electronics company. And we produced very high-end blood analyzers, where they would have analyzed blood sold to hospitals and such. And my buddy and I, Chris Russell, were into audio in a big way, and we decided we'd use all these very high-quality, high-tolerance parts that we'd use in the blood analyzers and build an amplifier.
Oh, that's cool.
The main difference is this, that most power amplifiers have a power curve. Think about like the torque in your car. Mm-hmm. When there's that sort of point at which everything's working right. You get maximum pull, maximum efficiency. With a power amp, it's typically about 1/3 power.
All right, so James, can you tell us what inspired the development of the Cubed series of amplifiers?
The development was by a young fellow that came to us a couple of years ago by the name of Alexander. And he had come up with a new circuit that he thought was sort of revolutionary overall. So we invited him to come to Bryston, and he ended up working here for us for a couple of years, and developed a circuit that we felt was an improvement over what we were currently doing in the SST squared, and decided we would move forward with it and call it the Cube. The main difference in the Cube version versus the SST2 version is, in fact, the input stage, this section right here. And that was developed by Alexander. And it basically has an extremely low distortion relative to what we're currently using. And as a result of that, it's almost 10 times lower overall. Mm-hmm. As a result of that, the input stage is really the main change that occurred. The output stage and the main circuitry within the amplifier remained relatively the same. So it's basically the input section that changed totally to become the Cube version. And we felt it was enough of a difference in terms of the sonic characteristics and the measurement characteristics that we would move to a different product, and then develop the new cosmetics to go along with that.
Okay, and so what sonic characteristics can we expect from the new series?
It's It's different in the sense that the things that sort of matter most to an audiophile tend to be that presentation of the soundstage, the three-dimensional aspect of it. You're sitting there and the instruments and the singers are in the room with you. And I feel that's what the Cube does even better.
Summarizing what we did learn from Mackintosh and Bryston. Working away from clipping at 1/3 of maximum power is a sweet point of any amplifier. Following a good audiophile amplifier should have significant power capability. 500 watts is optimal for majority real-life scenarios to drive 100 watt to 300 watt capable speakers at optimum listening volume. Soft clipping circuits are recommended to protect speakers from distorted signal. Monoblock architecture is part of the high-end amplifier design due to the flexibility to locate amplifier close to the speakers and 100% stereo channel separation. Preamplifier circuits are making a real difference, and it is important to build the good one. It has an influence to soundstage and improve details of the produced sound. James Bryston. Nice fancy appearance rising costs up to 30% with no impact to sound quality. Mackintosh. Elon Musk philosophy. Elon Musk is one of the 21st century extraordinary people capable to see things differently. What I really like in this person is ability to look behind the traditional thinking and start to do things in a new way without fear of failure. Once he said, "There is no logical reason why NASA programs are so expensive. I can adapt it to audiophile market. There is no logical reason why 300 watt audio amplifiers should cost 5K. What is the right price for a very good power amplifier? I would say this is €1 per watt per channel. For example, the best 500 watt stereo audiophile grade amplifier should cost no more than €1,000. Setting up requirements for Perfect Amplifier. Monoblock design, for sure. 300 watt 4 ohms audiophile quality plus 3 dB headroom, almost double power. Total harmonic distortions below 0.1%. Signal to noise ratio below rated power 100 decibels. Amplitude frequency linearity within 0.3 decibels. Possibilities to locate near speakers. Soft clipping. Best possible preamplifier circuits. Lightweight and small design. Electromagnetic interference certified. 110 and 220 volt mines. Weight below 2 kilograms per channel. For myself, I set an end-user target price of €350 for the 500 watt monoblock amplifier. It is a bit challenging, but why not? We can always do corrections at the end of the project. Choosing the OEM module. The first step is to choose a good OEM model for our design. To meet the total weight requirements, the switching mode power supply is the only option. There are a lot of advantages using the latest generation resonance switching mode power supplies, especially when we are talking to the high instant current capability, size, weight and protection. But it comes with a cost of certification requirements. So, I need an industry-approved OEM module for my amplifier. After careful study of later generation 500 watt capable amplifier models, there is a short list of two manufactured products, ICEpower125ASX2 and Hypex Encore 500. By specifications they are close, each of them has its own advantages. Hypex has auto switching 115 and 230 volts. The ICEpower model hasn't. They use a manual jumper. We need to make variations for 220 and 110 volts countries. ICEpower has a lower weight and optimum dimensions, reducing shipping costs. Hypex is capable to drive 2 ohm load. ICEpower 3 ohm load in a bridged connection. Hypex may have an advantages in very bad speaker crossover design cases. Hypex has single-ended solution where we need to consider bus pumping effect at low frequencies and high power. ICEpower will be driven in the bridged configuration where the bus pumping effect isn't present at any load. Hypex has built-in balanced input without an option to add custom-made preamplifier. Actually, this was one of the main reasons for taking the decision finally choosing ICEpower module over Hypex. Custom-made, exceptionally good preamplifier will be my key differentiator between a number of existing designs in the market. ICEpower has option to run it in a bridged and single-ended mode, giving extra flexibility for future projects. I do have projects for multi-amplified solution with an active crossover solution. This is a next generation audiophile trend giving fantastic listening tolerance, even driving mid-class speakers. Some business considerations. Price. Hypex manufacturer price was significantly higher than ICEpower. I can't meet the target price of the final product. Hypex designs are already saturating the market. There are a number of companies selling similar designs, and it is just a matter of time when margins will go down. Hypex as a manufacturer has its own integrated designs to compete with. ICEpower strictly keeps OEM manufacturer policy. After considering the pros and cons, ICEpower125ASX2 with custom-built preamplifier is my final choice. Let us take a closer look at our selection. Indeed, this module is one of the most successful ICEpower company designs. Key specifications: 450 watts at 4 ohms in bridged connection, max at 550 at 10% distortion. Possibilities to use in single-ended stereo configuration, important for future projects. It could be driven in the asymmetrical configuration, great for two-way speakers where two 4 ohm woofers are connected in parallel. A very interesting option for two-way active speaker projects. Excellent total harmonic and intermodulation distortions. 24 volts dual and regulated auxiliary power supply is perfect for driving a preamp voltage stabilized for 15 volts. I as a designer will have a full control over amplifier power supply quality, perfectly meeting my requirements for the highest quality preamplifier design. Selectable mains, able to work around the world. Key features: fully integrated audio power solution, a rugged construction, thermal protection, important, overcurrent protection, sound optimized soft clipping, all possible electromagnetic certifications. I can officially sell my designs around the world. Audio specifications at bridged mode. It has exceptionally good sound quality up to 350 watts at 4 ohms. Industry standard connectors. Very good audio specifications. Frequency response like a measurement instrument, almost hard to believe. Output impedance at low frequencies where we need most of the power and have a crossover dips as low as 18 milliohms or 0.018 ohms. It brings a damping factor of 220 for 4 ohm load. 100 is excellent. We are twice as good as excellent. BTL sync pin. ICEpower125ASX2 module has a dedicated bridged application sync pin to set modulator in a sound and total harmonic distortion optimized mode, important for minimum total harmonic distortions and the linearity. Auxiliary power supply. The smart engineering solution was to include a dual 24 volt auxiliary power supply. Why it is important? Preamplifier quality is significantly influenced by the power supply quality. In this solution, my preamplifier circuits need 50 mA. We did serious filtering of incoming power supply using high-frequency suppression beds and dedicated linear voltage stabilizers to deliver super clean ±15 voltage to ENA 1650 balanced preamplifier. Protection. Excellent protection is making our designs foolproof and long-lasting. It would be important offering extended warranty. Low mains. Temperature protection, overcurrent protection, over-temperature protection for power supply and amplifier separately. Input-output interface. The single-ended input buffer has an anti-aliasing filtering and DC blocking capacitors. The input impedance of the signal input section is a minimum of 8 kΩ, covering the audio bandwidth, which is acceptable loading conditions for preamps, active crossover inputs, etc. In the forums, I have read stories when unexperienced designers put 100 kΩ volume regulators without preamplifier stage and complained about the high frequency losses. Look to the anti-aliasing filter RC circuits. With your 100 kΩ potentiometer, you are extending high frequency suppression filter to audio bandwidth. Everything is by the book. According to the AES standard, preamplifier output impedance should be in a range of 150 to 600 ohms. For consumer units, you can go up to 1 kΩ. Output stage. The output stage is half-bridge topology with second-order filter. The filter design is a part of ICEpower proprietary MECC topology and has been chosen as the optimum solution between the modulation characteristics, efficiency, and filter compactness. The essential characteristics are the switching residual on the output primary consists of single frequency component and the carried fundamental FS. In simple, filter is very good. MECC, a novel control method. I was curious and find out what MECC means. It is a doctor's degree research on how to develop a superior quality Class D amplifier. That study has first presented in 1998 in AES conference in San Francisco. Pros and cons. Pros. High quality professional OEM module. 3 ohm load in BTL connection. Excellent protection. Soft clipping. Electromagnetic interference certified. Exceptional characteristics. 350 audiophile quality plus 150 watt power headroom. Amplitude frequency characteristics within 0.25 decibels. Available in eBay. Cons. Missing balanced input. In my case it's a feature, because I'm developing my own. No need to pay for integrated ones. Cost optimization. Unregulated auxiliary voltage. In my case it's a feature, because I am developing my own high quality ±15 volt stabilized power supply for the amplifier. Inverter needed for a BTL connection. I'm using one chip inverter with the highest dual signal tolerance possible. Selectable mines for 110 volts countries and 220 volt countries. Should live with the jumper settings according to the region. Preamplifier and balanced input. René story. Steve McCarthy René. René Note 151, written in 1995, revised in 2002. Probably this is one of the most important parts of this video. The goal of this chapter is to fundamentally understand balance and input benefits and principles. For your references, I did put a link to the René web and encourage everybody to read about the science of equipment wiring. And thanks René for putting everything together. Mixing balanced and unbalanced worlds. René wrote a document explaining balanced and unbalanced connection. It is a sophisticated topic where even professional engineers are making mistakes. It is critically important for any audio enthusiast to understand the basic principles of audio equipment interconnection. more and more high-end audio equipment has options for dual connection, mixing balanced and unbalanced word together. It's becoming a nightmare for home studio owner jumping over this interconnection topic fence. One may ask, if the balanced solution is the best, why isn't all equipment designed this way? Well, reality takes hold, unbalanced happens. Back in the early days of telephone and alternate current power distribution, a specific class of engineers evolved. They learned that telephone and AC power lines, due to their inherently long runs, must be balanced to achieve acceptable performance. To these days, many telephone lines are still balanced and unshielded. In the 1950s, hi-fi engineers developed systems that did not necessitate long runs and use unbalanced interconnections. The less expensive nature of an unbalanced interconnection also contributed to use it in a hi-fi. These two classes of engineers evolved with a different mindset, one exclusively balanced, the other exclusively unbalanced. The differing design experience of these engineers helped form the familiar balanced and unbalanced audio worlds of today. Grounding and shielding audio devices. You can find a lot of explanation of balanced input benefits. I will draw your attention to two of them. The first is putting our precious audio signal equipment in a Faraday cage by shielding. We will eliminate a lot of electromagnetic noise sources just properly shielding signal cable and enclosures. The second big benefit is a common mode rejection effect where noise signal can be eliminated up to 90 dB level. The lowlight is that even one unproperly designed and grounded device in a sound equipment series can ruin complete system. Here you can see the best scenario and all your signals are balanced. All of them in the picture are the same, just using three most common connectors. Standard mistakes. A standard mistake is connecting shield ground to signal ground, like one of the left side on a figure. It is important to remember that for balanced microphone or signal cable, pin 1 is a caches ground. This is a typical beginner mistake, especially when we have experience only with consumer devices, without balanced architecture. Inside of equipment, there could be a point where caches is connected to signal ground, but it should be done with the understanding of basic grounding principles, but we will not discuss there. More information is available in Texas Instruments publicly available application notes. Star ground schema. For high switching current devices like Class D amplifiers, proper grounding is even more important. Star grounding principle should be applied for signal grounding. Typically, manufacturers are giving best practice recommendations. This is one of the reasons to use proven manufacturer OEM model over unknown design boards. Interconnection. In the real world, we should interconnect devices. There you can see all possible scenarios of how we can interconnect equipment. We are interested only in two scenarios. Balanced, source to balanced input, and unbalanced source to balanced input. Our scenario. Let's take a closer look to our scenario. The first one is simple. We just take microphone cable and interconnect our equipment. For properly designed balanced outputs and balanced input, we can easily go for a couple of 100 meters without hum noise. Let's remember that connecting amplifier we are dealing with a relatively large signal comparing to microphone line level. So the distance could be even longer, up to 600 meters. Second, unbalanced to balance. The best way is to use RCA to XLR adapter cable and connect it in a way shown in a picture. In this case, we do have a short 1.5 meter RCA cable adapter connecting to long microphone cable, still partly shielded signal cable. This was one of the reasons why we don't implement an RCA connection in our design, forcing customer to use a proper connection in case of using connecting cables longer than 3 meters. Common mode ejection ratio, CMRR. Dear listener, this part will be a bit boring, but I recommend focusing for 5 minutes. If you are interested in audio, it is critically important to understand balanced and unbalanced connection principles at basic theory level. Unbalanced cables and signals. An unbalanced cable consists of two connectors with two conductors each, connected by two wires inside the cable, a signal wire and the ground wire. You can quickly, in most cases, identify the cable designed to carry an unbalanced signal by its connectors. Because each wire has to terminate at the connector with its own contact point, an unbalanced cable requires only two conductors at the connector. A standard TS or tip sleeve guitar cable is an unbalanced cable you run into the stage most. Standard RCA cables used for many audio-video components are also unbalanced cables. Inside the cable, the signal is typically in the center of the cable with the ground wire surrounding it. The ground wire serves two functions. It carries part of the audio signal and serves as a shield to main signal wire to some degree from the outside interference, noise, such as a hum noise from lights and transformers, as well as radio frequency interference, what comes from TV and radio transmission. It does a decent job of rejecting noise, but unfortunately the wire itself also acts like an antenna and picks up noise. Unbalanced cables were great for connecting a guitar to the amplifier, for instance, but because they are not very good at suppressing noise from outside interference, unbalanced cables should have a maximum length of 3 to 6 meters. Balanced cables and signals. In a balanced transmission system, the audio signal transmits over two signal lines differentially, 180 degrees out of phase. Electrical interference tends to be introduced into the both signal lines, with equal magnitude and equal phase. Therefore, subtracting signals on the one conductor from the other will recover the audio signal and remove unwanted interference common to both signal lines. And as you can see, it works equally fine for analog and digital signal transmission. Because of this, balanced cable can support much longer cable runs, more than 100 meters. Today is not common thought even shorter runs will often use balanced wiring to protect against noise. Standard connectors designed for use with balanced signals are XLR and TRS, tip ring sleeves. Designing for high common mode rejection and balanced audio inputs. For those who want to learn more, I would recommend reading Texas Instruments provided application notes. We will not go through this slide in details. I would like to draw your attention to those two resistors. In an unbalanced connection, you are missing one. There may be scenarios where you need to put a resistor in series between shield and ground point in the connector to improve the signal to noise about 50 to 100 times. There are a couple of examples of the line drivers. For those who are not very good at audio language talking in decibels, I added a reference table to get some quantitative estimations of what numbers are behind the decibels. You can always come back to this slide and benchmark one or another statement. Designing balanced preamplifier. This is where we want to be the best of the best. Let us remember what James Bryston said about the cube amplifier benefit. One key differentiator of the perfect amplifier was the preamplifier circuit designed by engineer Alexander. So, for our design, we took the latest generation Texas Instruments chipset INA 1650. To design balanced input with a high common mode rejection, we need a high tolerance passive component match. The best way to achieve it is to use on-chip resistors using the same chemical and lithography process. We will be able to achieve 0.01% component match, what wouldn't be possible using external components. This chip integrates input buffer and suppression filter, ensuring the best of the best performance. And finally, the chip has exceptionally low 120 decibel total harmonic distortion. This is more than 100 times better than we actually need. Does it come with the costs? Yes, this preamplifier is 10 times more expensive compared to simple discrete components balanced design, what typically is integrated into amplifier modules. Is it better? Yes, it is. It is far better in all aspects. Will it raise amplifier costs? Sure. but it is worth any penny when we are aiming at the best possible quality and reliability. How do we compensate it to meet a target price? We will take rational decisions choosing connectors and enclosure design, keeping it simple and aesthetic. INA 1650 specs. Let us take a brief look to the specification. High common mode rejection, 91 decibel. The theoretical maximum is 100 decibels, achievable by specific passive super precise balanced audio transformers. High input impedance 1 megohm in differential connection, excellent. Ultra low noise, minus 104 dBu unweighted. For us it simply means noiseless. Minus 120 decibel total harmonic plus noise to the low bandwidth. It is 100 times better than best of power amplifiers so far designed. Wide bandwidth, low quiescent current, short circuit protection, integrated electromagnetic interference filter, good for the best of the best. Wide power supply range, available in a small package, good for final board dimensions. Here you can see functional diagram. There are 2 channels on the chip with a perfect components match. Let us take a closer look. The input buffers prevents external resistances such as those from PCB connectors and cables from ruining the precise matching of the internal 10K resistors, which would degrade the high common mode rejection of the differential amplifier. Electromagnetic interference filtering is added to the input buffer to prevent high frequency interference signals from propagating through the audio signal pathway. All around, greatest of the greatest. Here is a simple application circuit, just a brief look without comments. And how good is chosen solution? Actually, it is very good. It is 100 times better than similar designs developed using discrete components. And it is worth any penny, especially when connecting together with the latest generation digital analog converters. You will have a surrealistic feeling that sound is coming from absolute silence. And one more reminder of how to connect to device in balanced and unbalanced scenarios. Commercialization. The idea isn't new. There are similar designs in the market. For example, the left one has a box from the monolith CNC milled aluminium, Hypex 2x500 watt module using onboard balanced inputs. Everything is done with a love to the project. The only concern is the heat dispatch. This Hypex module has a kilowatt capacity that we are dealing with a 20 watt continuous idle heat dispatch. It is hard to dispatch heat through the compact sealed aluminium case. Continuous high temperature may reduce the lifespan of the Hypex module, draining out electrolytic capacitors. When you develop your design, think and learn how to calculate heat dispatch. It will distinguish great designs from the good ones. Belcanto design has a large box and half power to be dispatched. Good competitor, relevant design. China Designs has been in the market for 5 or more years. This company is specializing in box design for popular OEM Class D amplifier manufacturer models. I haven't heard much in the forums. Strange. Apollon Audio, using ICEpower highest power modules and nice boxes, utilize onboard preamplifier circuits, targeting high-priced audience. There are variations of offerings. Belcanto similar design to China company, with a higher price tag. Nordic Acoustics, similar approach, but better overall pricing. Winning sales strategy. Could we win? This is a question what any businesses should use. Finding our strengths and weaknesses before starting design is critically important for success. In large companies, marketing and product specialists are those who set up requirements for the new products. Those are not engineers. There is a summary of our team brainstorming before this product has been developed. Pros: exceptionally good quality amplifier matching top manufacturer's specs and exceeding human physical hearing capabilities. Satisfying broad customer demand in power range from 50 watts and above. In-house caches design and production options, significant advantages and flexibility. Good brand OEM model with the warranties and support. Optimized caches specially developed for ICEpower125ASX2. Best-in-class Texas Instrument balanced input chipset preamplifier suitable for the professional market. Considered a competitive advantage, part of the marketing message. Balanced and unbalanced connection with the same input. A bit innovative approach, we need to wait for customer feedback, good for high-end equipment connection. Lightweight for easy handling and shipping worldwide. Important, significantly reducing shipping costs per unit, competitive advantage. ICEpower125ASX2 is not manufactured in China. There are limited risks to be copied and replicated for a very cheap price. A unique small footprint and lightweight design allowed near speaker placement may be considered as a competitive advantage because eliminating the length of the speaker cable. Audiophile grade speaker cables are very expensive. Cons: small company designs need extra time to be accepted by the market. Challenging to address larger market demands due to the limited cash flow. Need to establish a sales channel. Strong competition. Target customer: rational audiophile, those who want maximum value for their money. It is critically important for them to explain and deliver proof that the unit really is good. Audiophiles who want the second unit to the main system. Many audiophiles upgrading their speaker through the years. Not all of them are selling old ones. They do not want to spend too much money on the second system. We believe that our design will fit well in those scenarios. Studios as a references or installation amplifiers. Who knows? If the unit will earn good references, this market can open as well. Installation amplifier. With 500 capability and remote connection via balanced input, this unit may drive arrows of small speakers at the remote location. Low idle consumption, low having always on scenarios. DI market. Caches with assembled components. Good price, but not offering warranties. Addressing the price-sensitive market where you can build your personal system, saving 30% of the budget. The hidden price to pay there is the risks. There will not be warranties and technical support. It is important to set the right expectations for potential customers. Sales channel. Any company can produce something. The tricky moment is how to sell. Large companies spend years building and establishing sales channels. And there is tremendous manpower spent to make it work. Did you ever ask why big brands practically are not presented in eBay? This is due to the eBay has high cost of sales. When you do proper calculation, those are close to 20% plus shipping around 5%. The total cost of sales are close to 25%. And if you do promotions to make your product visible, extra 10% of marketing. Large brands focusing on established channels, those who are able to make forecasts and predictable quantities purchases. All those activities reducing production costs and shortening money turnover time and cash flow. When we start large quantity design projects, we need transit time until the mentioned channels becoming available. So, in the beginning we still rely on internet sales like Amazon Prime, sales channel, eBay, direct using landing page, and in the future, reseller channel development and some large music equipment reseller or distributor. Marketing strategy. YouTube videos and promotions, customer video stories and tests, professional references from audio world people and names, new DI projects and cross-references, detailed design guidelines and how-to videos, Facebook ads, maybe YouTube ads. Prototype. Enclosure. Based on previous considerations, we started with the enclosure design according to the following requirements. Simple, minimum footprint, easy to produce, aluminium, self-clinging nuts and spacers, input circuits close to the input connectors. Optimum component placement will allow to assemble a unit without a need for shielded cables and automate connection cable production. Actually, it is a significant saving of manpower costs for assembling. We managed to keep all signal connection cable lengths below 100 mm. It is okay to just twist the cables to achieve maximum performance. No need for shielded cables inside the caches. Preamplifier is placed to the back panel near input connector. On-off switch near the mains. Power on indicator on the front panel. The layout is highly optimized for proper connections. The preamplifier has SMD design for minimum footprint and robotic-only soldering. Clipped connectors between the two boards are used, and ROH compliance. Design. Aesthetic and minimalistic. Step away from traditional black and silver designs to stay out of the crowd with memorable colors. Model name VH500. No heavy gauge front panel. Aluminium, powder painted. Balanced XLR input only. High density plastic connectors. Removable feet for wall mount options. And there is a final look at the product. Packaging. The packaging is a significant part of marketing. There we asked professional designer company support. We have a long-time relationship with this company. There are not many companies specializing in industrial designs. Green thinking is important for us as well, so our package will be paper only. Important part is a printed text on the box. We choose a technical approach. There will be a lot of text explaining preamp and amplifier quality with the text specs. All around I'm happy with the end result and printed text. Could you do without design company support? No, we can't. Doesn't matter what we thought about initial design by ourselves, version what comes back from the design company were far better. They simply have a taste and knowledge of how colors and shifts play together. Options. Enclosure with a preamplifier and assembling only. Offered with no warranties and returns, targeting the DI audience and cost-sensitive market. The estimated total system price difference of 30%. Option 2. Monoblock amplifier with power cord, available in sales per unit. Option 3. Stereo package, our target sales offering. 2 monoblock amplifiers with power cord, 2 XLR 10-meter microphone cables, and 2 RCA to XLR adapters. Setting customer expectations. Typical customer dissatisfaction is coming from the too high expectations. Nevertheless, I did remind my listeners that today's good amplifiers are exceeding human hearing limits. People are still waiting for the miracle. When you have 100-watt good amplifier at home and purchasing 250-watt amplifier, the step up is minor, because to feel and listen twice louder sound you need 4 times more power. And what customers are saying, I expected from my new investments more. Expectations was set too high. A real step-up feeling would be moving from 100-watt amplifier to 400-watt amplifier, with emotion of wow and what's the thing. Let us remember what James Bryston said about amplifier sweet point. Yes, you are right, 1/3 of maximum power. Want to serious step-up from 100-watt amplifier, you need a 500-watt amplifier to drive 100 to 300 watt capable speakers, using 1/3 of maximum power. There is a formula what I borrowed from the large consultancy company. What is customer satisfaction? It is an experience minus expectations. The higher are expectations, the lower is satisfaction. Even experience is great, and vice versa. Blind test experiment. Whether or not amplifier sounds different is a subject of ongoing controversy. There are sensible, well-informed enthusiasts and magazine reviewers who will swear that there are obvious differences that are to them almost as obvious as the importance of the difference between the speakers. There are also just as many well-informed enthusiasts and reviewers who say that there are no meaningful difference in the sound of two properly functioning, properly performing amplifiers operating within their undistorted performance envelope. And there is a third contingent that opinions that the in-situ applications of different amplifiers with different speakers and other associated equipment and connectors can produce a difference. I experimented with the listening passive studio monitors in a blind test using a good studio amplifier and ICEpower ASX2 amplifier prototype. After careful volume alignment, I was not able to distinguish difference how they sound continuously one-click switching between amplifiers. Of course, it was done well below the clipping level, so I'm giving my vote to the second opinion audience. Setting customer expectations. By setting customer expectations, I would say that customer who has good 250 to 300 watt amplifier shouldn't invest in my design. There will not be an audible improvement. Those who have 100 to 150 watt system will have significant feeling that there is improvement due to the extra undistorted power headroom, as well as driving amplifier at the sweet point of 1/3 of maximum power. Sound will be richer, mids precise, details will show up, low frequencies become rich. 3-ohm load capability will deal better with three-way systems, giving extra clarity and neutrality to sound. Second big improvement will be ability to locate monoblock close to the speaker and avoid thick wires or B-wiring. Balanced input architecture allows locate speakers at any distance from control center without signal degradation. A low idle power consumption, enabling always-on amplifier operation. Things to avoid. Like any equipment, there are some operation scenarios to avoid. Scenario 1. The power switch has a spring-load mechanism for fast and sharp connection. Some people don't like on-off switch sharp click noise, and they try to control switching speed to make the noiseless on-off switch. This is bad practice, because the spring-load mechanism means to avoid sparkling when switching on. Slow switching may reduce switch lifetime. Scenario 2. Driving amplifier at max power with Cinewave. For example, trying to measure total harmonic distortions for maximum power in a bridged mode. ICEpower125ASX2 has been designed for music applications. It can deliver continuous 500 watt music capability with confidence. But it cannot dispatch heat running Cinewave test signal at 500 watts. The normal music spectrum has a power density of 1/8 of Cinewave. If you run 500 watts Cinewave to the ICEpower module for about 30 seconds, the thermal fuses will blow up. ICEpower engineers did built-in special electronic component to protect the board from inexperienced engineers not reading manuals. It is small damage to the board, but you need a replacement thermal fuse component to fix it, and it is soldering process. And finally, things to remember. Exceeding human hearing limits, driving real crossover load, Elon Musk's statement, James Bryston, amplifier sweet point, James Bryston, the importance of preamplifier, balanced and unbalanced interconnection, and setting customer expectations.